In Algebra 1, we've started a new section on systems of linear equations. Today we're going to talk about the topics of solutions and graphing. First, let's get a definition. A system of linear equations is two or more linear equations with two or more variables. The first thing we're going to talk about is the solutions. A solution is just an answer, or in this case an ordered pair, which satisfies both equations. In a system. To figure out if something is a solution, we're going to plug in the x and y to each equation. So let's go ahead and look at some examples. In this first section about solutions, example number 1, we have the point 1, 3, and we have the system 2x plus y equals 5, and negative 2x plus y equals 1. So we've got a system, two different equations. We've got an ordered pair, a solution. We want to test and see if it works. So we have an x and a y value. We're going to plug them into the first equation and see if it really does equal 5, and into the second and see if it really does equal 1. And if it does on both accounts, then this is a solution. So 2 times 1, because that's our x value, plus 3 equals 5. 2 times 1 is 2. I copy everything down around it. 2 plus 3 is 5. And so since 5 does equal 5, that part is correct. Let's check in the second equation. Negative 2 times 1, that's our x value, plus 3, that's our y value, is equal to 1. We have to follow PEMDAS, so we multiply. Negative 2 times 1 is negative 2. Copy everything else down. Negative 2 plus 3 is 1, and 1 does equal 1. So yes, 1, 3 is the solution to this system. Let's look at another example, number 2. I have the solution to negative 1, and I have the system x minus 2y equals 4, and 3x plus y equals 6. Let's go ahead and test that out. We have an x and a y. So for x, I'm going to put 2 minus 2, and in parentheses, negative 1 equals 4. I follow PEMDAS, so I multiply right here first. Negative 2 times negative 1 is positive 2. And positive 2 plus positive 2 is indeed 4. That one checks out. The second one, 3, and in parentheses, for x, we're going to plug in 2 from right here. For y, we're going to plug in negative 1. 3 times 2 is 6, plus negative 1 is the same as saying minus 1. And 6 minus 1 is 5. Here it says 5 equals 6. That is not true. So the answer to this one is no. 2 negative 1 is not a solution to this system. Now, if you had tested this and the first one did not work, you would say no, and there'd be no point in checking the second, because once you get a no, the answer is no. The second thing we talked about in this lesson was how to solve systems by graphing. I'm going to give you the steps on the front side and the examples on the back. It is also worth mentioning that there are 3 ways to solve systems of equations. Those are graphing, substitution, and elimination. Today we're just concerned with graphing. Step number 1 is to solve for y. Step number 2 is to graph using y equals mx plus b. And you should remember from the first semester that m stands for slope and b stands for the y-intercept. So we're going to need the slope and the y-intercept to be able to graph. And step 3 is to find where they cross. Okay, let's look at some examples. We're just going to look at 2. So example number 1, the system is y equals negative 2x minus 1, and y equals x plus 5. Now again, to graph these, step number 1 was to solve for y. We've already done that. As you can see in both of those, we have what y equals. I'm just adding a little graph here for us to use. Next step is to use mx plus b. To do that, we're going to start with our y-intercept. On this equation, it's negative 1, so we start there. And our slope is negative 2, so we're going to go down 2 and over 1. Don't forget, if it's a whole number, we just put 1 on the bottom so we know to move over. Also, it's important that every time you move to the right, if you don't move to the right, you go backwards, you're going to get confused and probably not get a correct answer. Then use a ruler to go ahead and connect those and connect it all the way through. So we want to see where it crosses eventually. For the second equation, our y-intercept is 5. We'll plot that. Our slope is the number in front of x, which is just 1, or 1 over 1. So I'm going to go up 1 over 1 and continue in that fashion until I get some points. And once I've got several, I can connect. And I can see where those two cross. And that place where they cross, in this case, -2 would be my x value, and 3 would be my y value. Those two places right there, -2 and 3, is my solution. Okay, let's look at, I'm going to mark that as example 1. Let's look at another one, example number 2. The system is y equals 1/3 x minus 3, and 2x plus y equals 4. All right, now, to do this, we need to get the second one into y equals form because it's not already. So I'm going to subtract 2x from both sides, and y equals -2x plus 4. Now I'm in business with that second equation. Starting with the first, my y-intercept is -3, so I will plot that, 1, 2, 3. And then my slope is 1/3, so I'm going to go up 1 and over 1, 2, 3, and do that again. Be sure you count carefully. If you get off in your count, that'd be a real easy way to mess this up. And then my next one is to start at 4. My slope is -2, so I'm going to go down 2 and over 1. And I will repeat that pattern until I can see where those two cross. In this case, they cross right there. Be sure you're getting the correct two lines. And that solution is 1, 2, 3. And down 2. And so it's 3, -2. The assignment for this was practice C. Good luck. Let me know if you have questions.